Welcome back, dear students, to my channel. Let's continue with the chapter on triangles. We are doing the first exercise, and in the last video you were introduced with the criteria for showing two triangles to be congruent, isn't it? So we have learned 5 special criteria, remember? Okay, so we'll make use of those in today's sums. Okay, so let me take question number 2. Question says, the given figure shows a circle with center O. Okay, so I haven't written out here, it is O out here. Okay, this is a circle with center O, and P is the midpoint of the chord AB. Okay, so AB is the chord and P is the midpoint. Show that OP is perpendicular to AB. So you know, from O, if you drop a perpendicular, if you draw a line which bisects, see here carefully, you have this line. Okay, so here you see this cut is there, so this cut represents that AP and PB both are equal. So in other case, here what happens is this line from the center is bisecting this chord AB. Okay, bisecting the chord AB, right? Now what we need to show here is we need to show that this line is perpendicular to the line AB. Okay, remember P is the midpoint, so AP and PB, they are equal. Okay, right. So we need to prove that OP is perpendicular to AB, or in other words, what I can say here is angle OPA is equals to 90 degree. OPA, okay, OPA means this angle is 90 degree. That's what we need to show here, right? All right, then what am I going to do is I'm going to join OA and OB. Okay, I'm going to join these two. So let's see what do we get after we join. So if we join, we are going to get line like this or diagram like this. Now see, in this red thing which I have done extra, I have drawn this line. This means that OA and OB, they are equal. Now why are they equal? That's my question. They are equal because they are, both OA and OB represents the radius of this particular circle, and all of you know that radius will be same wherever you measure. Okay, so you have OA and OB will be equal to each other because they are the radius. Okay, now in triangle OP and OPB, remember the corresponding part of OA is O, corresponding part of P is P, corresponding part of A is B. Okay, right. So in triangle OPA and OPB, now just observe this carefully. What happens is OA is equals to OB, isn't it? Okay, and one more thing is given, AP is equals to PB. This is given because P is the midpoint. This was given in the diagram. Okay, now what you can see here is you have OA is equals to OB because they are radii, isn't it? And one more thing is, one more side of the triangle, you know, is there, which is common to both the triangles. That particular side is OP. Okay, this OP is present in triangle OPA. Okay, OPA, and OP is present in OPB also, triangle OPB also. Okay, so that's why OP is common. So here what I showed is three corresponding sides are equal to each other. So using which criteria they are congruent? Using SSS. Okay, because side are given out here. Okay, so first side is in blue color, second side is in red color, and the last part is in black color. Okay, so using SSS criterion, we see that these two triangles are congruent. And remember what you need to show here, you need to show that triangle OPA is equals to angle OPA is equals to 90 degree. So by corresponding part, see, since these two are congruent, you know that not only the corresponding sides but corresponding angles will also be same. So that's why by CPCT, corresponding parts of congruent triangle, what I can say here is I can say that this OPA, this triangle, this angle is equals to angle OPB, which is this angle. Okay, so this is by CPCT. Now just look at this carefully. Tell me what is the value of angle APB. Isn't this 180 degree because this is a straight line? Yes. So we know that one more thing that we can say is, if you add OPA and OPB, these two angles, this angle and this angle, you'll get angle APB. This entire angle you will get, isn't it? So if you add this angle and if you add this angle, you will get the entire angle APB. Simple, right? Okay, so all of you know the value OP and OPB both are same. Now in place of OPB, I'll write OPA. Okay, so if you write OPA plus OPA is 2OPA, and APB is a straight angle. Remember, this entire angle is OPA, right? APB, which is 180 degree. So therefore, if you bring this 2 out there in the denominator, you get 180 by 2, which is 90 degree. And that's what we wanted to show, isn't it? So that's why we say that OP is perpendicular to AB, and that's what we wanted to show here. All right, so you may pause the video and note down your solution. Right, so we have got a similar kind of question out here. So question says, the following figure shows a circle with center O. Okay, now in this case it is not given that AP is equals to PB. In the earlier question it was given AP is equals to PB, but this time it is not given. It is given OP is perpendicular to AB. This time this is given, so this OP is perpendicular to AB. Now you need to prove that AP is equals to BP. So this is exactly opposite of the earlier question, isn't it? Earlier AP is equals to PB, that was given, and you were asked to show that OP is perpendicular. But this time OP is given to be perpendicular and you are asked to prove that AP is equals to PB. Okay, so let's see how to do this. So we know that we want to prove AP equals to PB. Okay, so again we'll do one construction. We'll join OA and OB, and after joining you get somewhat like this. Now tell me what kind of triangle is this? OAB. This is going to be equilateral isosceles triangle, because this side and this side, they are equal to each other. They are the radius. So that's why this side OA and OB, they will be equal to each other, right? Okay, now so in triangle, as I said, if these two are, if this one, okay, so if this one and this one, if these two are equal to each other, then this is isosceles triangle, and in isosceles triangle the base angles will also be equal. So this angle A and angle B, they are also going to be equal to each other. Okay, right? So again we will observe these two triangle. Okay, so here it is given that this angle and this angle, they are 90 degree each. This angle and this angle are also same, and this is the side. So look at this, angle side is given from the diagram, angle side. Okay, so this is already given, as I said, OP and OPB, they are equal, and they are equal to 90 degree each. Okay, angle A is equals to angle B because it is isosceles, as I said. Okay, and OA is equals to OB, angle side, isn't it? So that's why using AAS, these two triangles OPA and OPB, they are congruent to each other. So by corresponding parts of, by CPCT, by corresponding parts of congruent triangles, what we can say is AP is equals to PB. Okay, so we have AP equals to PB. PB also can be written as BB out here, right? So you may pause the video and note down your solution. Let's look at this problem. So in this problem there are 3 equations. Okay, so let's read the question carefully. So in triangle ABC, D is the midpoint of BC. Okay, so D is the midpoint of BC. Kindly remember this. AD is produced up to E, so that DE is equals to AD. Now what is the meaning of this? Let's try to understand using the diagram. Okay, so what is given is, in triangle ABC, D is the midpoint of BC. So in other words, I can say that BD is equals to DC or CD, because see, if you draw a line BC and in the middle if you plot D, then it becomes BD equals to CD, isn't it? So it is given. Okay, and one more thing that is given to us is DE equals to AD. This is also given to us. Now let's draw the diagram. Okay, so my diagram looks somewhat like this. See here carefully. So BC is there and D is the midpoint, so that's why BD and DC or CD, they are equal to each other. Okay, now next thing that we have here is, it is given that DE. Okay, so when you produce AD up to E, so when you produce means, remember, produce means to extend. Okay, so if you extend this AD up to E, so that this AD and DE are equal to each other, then we need to prove that triangle ABD and triangle ECD are congruent. So in order to make ECD, what we'll do is we will join EC here. Okay, right. So what we can observe here is, we have this angle and this angle, they will be equal. You know why? Because they are vertically opposite angles. Okay, so what did you observe here? Kindly look at this. So you have this side and this side, angles are also equal because there is a X kind of figure being formed. So whenever there's X kind of figure, all of you know they are vertically opposite, so they will be equal to each other. And you have one more side, so angle is lying in between two sides, two given sides. So obviously using SAS. Okay, so SAS, we say that these two triangles ABD and ECD, they are congruent to each other. That's what we wanted to show. This is my first part. Okay, first answer of this question. Next we need to show that AB is equal to CE. Okay, AB is equal to CE. Obviously since these two are congruent, AB's corresponding part will be CE. So that's why by CPCT we say that AB is equals to EC or CE. Simple, right? Now next part says you need to prove that AB is parallel to EC. AB is parallel to EC. Now again by CPCT, can I say that angle A is equals to angle E? Obviously, isn't it? So angle A, that is BAD, is equals to angle CED. Okay, this angle and this angle, they are equal by CPCT. Now just look at this figure, BAEC. Isn't this look like Z? And all of you know Z kind of figure being formed in the case of alternate angles. So basically I can say that angle A and angle E are alternate angles if A is your transversal. Okay, so that's why, see, since angle A and angle E are equal, then obviously your AE is acting like your transversal, and that's why if A is transversal, then automatically AB and CE becomes parallel to each other. So that's why I'm writing AB is parallel to EC in this case. Okay, so pause the video and note down your solution. Right, so we have number 5, sub number 1. There's one more part, I guess, that we'll see later. Okay, first let's look at this. So a triangle ABC has angle B equals to angle C. Prove that perpendiculars from the midpoints of BC to AB and AC are equal. What's the meaning of this? Let's try to understand. Given that, okay, so angle B and angle C are equal in triangle ABC. Okay, and it is said that you have to draw perpendiculars from the midpoint of BC. So what will I do is, I'll take side BC and I'll take the midpoint to be point D. So I've taken D to be the midpoint of BC. Now you have to draw perpendicular from the midpoint. So from midpoint we have to draw perpendicular to side AB and AC. So to side AB, if you draw a perpendicular, okay, so I'll name the name of the perpendicular to be DE. So I say that DE is perpendicular to AB. What I need to prove that is the perpendicular DE is equal to the perpendicular DF. Okay, so DF is perpendicular to AC. Remember. Okay, so as I said, we need to prove DE and DF, the perpendiculars, are of same length. That is, they are equal. Okay, now kindly look at this. See, what is given to us is angle B and angle C are equal. D is the midpoint, right? So D is the midpoint means BD and DC, they are equal. This is 90 degree perpendicular, this is also perpendicular. Now kindly look at this. Here we have angle, side, angle, side, isn't it? So in triangle DEB and DFC, what we have is this one. Okay, so this angle, which is 90 degree each. Next we have this angle, angle B equals to angle C. This is given to us. And the last side is BD equals to DC, because D is the midpoint of AC. So that's why using AAS, we say that these two triangles, these two small triangles are congruent. Now if these two sides are congruent, can you say that DE and DF are corresponding paths? Obviously, right? E corresponds to F, so that's why DE corresponds to DF, isn't it? So that's why we say by simplicity DE equals to DF. Now what is actually DE and DF? They are the perpendiculars from the midpoint. And I showed that the perpendiculars from the midpoint are equal to each other. That's what I wanted to show. Alright. So you may pause the video and note down your solution. Right. So we have, as I said, we have got one more part. Next part, let's see how to do the next part. So again, in triangle ABC, angle B and angle C are equal. The perpendiculars from B and C to the opposite sides are equal. Now you have to draw perpendiculars not from the midpoint. You have to draw perpendicular from B and C. Okay, so ABC is a triangle. From B you draw a perpendicular. Okay, so let's say BD is that perpendicular. Okay, and see, from C also you are drawing perpendicular. So name the perpendicular to be CE. So that's why I am saying BD is perpendicular to AC, right? You see BD is perpendicular to AC and CE is perpendicular to AB. Okay, you remember AB, angle A and angle C are also given to be equal. Okay, now we need to prove that the length of these perpendiculars are also equal. Okay, now let's observe triangle BEC. So BEC means this triangle. Okay, and the other one is B or CDB. Okay, this triangle BEC and CDB. Now two angles are equal in this case. All of you know this is 90 degree each, and one more angle are given to be, one more pair of angles is given to be equal. Okay, now in both the triangles, both the triangles, one of the side is common, and that common side is, from the figure you see this bold line in blue, that is BC. Okay, so BC is the side which is present in both the triangles and they are common. Now again, angle side is there, isn't it? So that's why using angle side, we have these two triangles, and triangle BEC and CBD, they are congruent to each other. Now remember corresponding sides. Okay, so we have using CBCT. Okay, so BC is gonna be equals to, okay, BC is gonna be equals to CE. That's what we wanted to show. Okay, so remember BD is equals to CE. That's what we wanted to show. Okay, so you may pause the video and note down your solution. Okay, so this is my last problem for the day. Thank you very much.